So there are 4 cones. From the first cone to fourth cone, to go to fourth cone he goes 20 meters and then comes back, so he travels actually 40 meters. Then he goes to the third cone. From the first cone he goes 10 meters and then comes back, that means he goes 20 meters. And then from first cone to second cone he goes 5 meter and then comes back, so he travels 10 meter. So we can see the series is something like that. And then there is, so this is A, which is the first term, is 40, and common ratio is R, which is 20 over 40 we can say, or 10 over 20, whatever it is, half. So that's the thing, and this is the series. So if more cones are added and the pattern continues, that means this series goes for infinity. So how much he has to travel in total? So in order to find that, which is question B, in order to find that, what we can do is we can find the sum for an infinite series. For an infinite series the sum is 1 minus r. So A here is 40, r here is, which is 0.5, so we get 80 meter. Now last one says that the coach asks for, if he runs in other way around, that means if the series becomes something like this, and if we keep adding the cones, it will become, r is becoming now 2, so this formula is becoming, it's not possible, because basically this formula is a minimization of this one, which is a 1 minus r to the power n. It's an approximation for the infinite case when r is less than 1. So if r is greater than 1, this one will reach infinity, so it's not possible, he has to run forever. That's why the reverse arrangement of the cones is not possible. One thing I need to tell about this formula, which is this one, s is equal to a 1 minus, for a finite series, 1 minus r. This one, r is, this formula is valid when r is less than 1. That means for a finite series this is, but when r is greater than 1 for a finite series, the formula becomes r to the power n minus 1, because if this for r is greater than 1, this formula, this will result in a negative sum, so not that, and then like that. So this is for, and then this is also becoming r minus 1. This is for r greater than 1. But for an infinite case, when the sum is for infinite case, then it's only valid when the common ratio magnitude is less than 1. That is, whether it's positive or negative, but the value is less than 1. Only then the common ratio is possible, the infinite sum is possible with this formula. So for an infinite series, when the common ratio r, the magnitude of common ratio is less than 1, then this formula is valid for an infinite series.